Elon Musk finally launches new light-speed engine that defies physics. Although there is so much to see and learn in space, exploration is severely hindered by distance. For instance, Proxima Centauri, the star closest to us, is 40,208 billion kilometers away. Elon Musk wants to inhabit Mars, but even that will take at least 5 months in space. So, is it feasible that Elon Musk and NASA have finally defied physics with their latest breakthrough? Because NASA is on the approach of developing a near light-speed engine that defies physics laws. A concept for an engine that can accelerate to 99% the speed of light while consuming no fuel. That may sound like something from a science fiction movie, but it is not. A NASA engineer is working on a similar project that has the potential to defy physics. So, how did Elon Musk eventually unveil his new light-speed engine, which defies physics? Let's dig into the details. To create a disruptive engine in-house that would reduce launch expenses, the goal is $5 million. NASA calls it a breakthrough, and Elon Musk describes it as incredible. Why? Because a tiny team of NASA engineers recently tested what is being labeled as a new form of rocket engine that is significantly more efficient than anything currently on Earth. And you might be wondering, how can one top something like that? What if I told you there are plans to improve it even more? Much improved. Basically, NASA has just successfully test-fired a new type of engine that promises to make space travel cheaper and faster. Most commercial and military rockets now employ chemical fuels that must be manufactured on Earth and then put into rocket boosters before the launch. This is not only costly and difficult, but it also restricts the amount of weight that can be raised off the Earth's surface. What about the new experimental engine? It runs on a different type of fuel, electricity, the kind you plug into a wall socket. It may seem far-fetched at first, but when you consider that 95% of everything you do in life requires consuming energy at some point, from running your vacuum cleaner to switching on a light switch, it no longer seems so far-fetched. Musk and a team of NASA scientists unveiled their design for the Raptor, a new rocket in September. It can sustain over 500,000 pounds of force and runs on liquid methane rather than typical kerosene, resulting in 30% less carbon dioxide emissions. However, because it can be launched into orbit, engineers must first demonstrate that it works on Earth. In an interview with Mashable Steve Jurczyk, Associate Administrator for NASA's Space Technology Mission Directorate, he said, "I'm hopeful that we'll be able to do short flights, sort of up and down flights, probably sometime in the first half of next year." But what exactly are they constructing? It's essentially a massive super heavy lift launch vehicle and booster rocket combination capable of launching 170 metric tons into low Earth orbit. In comparison, Falcon Heavy, SpaceX's newly operational heavy lift rocket, can lift 54 metric tons. That means that a single Raptor engine could theoretically replace all 3 first-stage Merlin engines now utilized on the Falcon 9 launch vehicle. The Raptor also differs from most traditional rockets in that it will run on liquid methane rather than kerosene, as has been the case since the 1950s. Methane is more environmentally friendly and less expensive to create than traditional rocket fuel, but it is also incredibly complex to handle. Because of the tremendous pressure and heat required to liquefy methane, traditional rocket engines cannot use it as a fuel. However, SpaceX appears to be working on a way to harness that power with Raptor. The experimental engine produces 420,000 pounds of thrust utilizing methane as fuel and liquid oxygen as an oxidizer, outperforming the existing US standard. Researchers working on a NASA-funded study have discovered that what is thought to be impossible. EagleWorks Laboratories completed tests of an electromagnetic drive (EM drive) under conditions resembling those seen in deep space. They also claimed that the tests indicate a thrust-to-power ratio of 1:4, which is greater than any of their calculations projected for such a device and could open up new avenues for deep space exploration. Other scientists have yet to validate the findings, so we don't know if they can be replicated until independent teams have their own EM drives and conduct their own studies. The EM drive is a contentious gadget. It violates Newton's third law, which asserts that everything has an equal and opposite reaction. So if you fire anything from a rocket ship, it will be propelled in another direction, even if it is only air molecules bouncing off that thing when it leaves. The EM drive, on the other hand, only provides push in one direction. Now, how does this rocket work? Elon Musk is bringing science fiction to life. His business SpaceX claims to have designed and successfully tested a propulsion system that defies physics. The rocket propulsion system is powered by electrically charged gas and may reach speeds of up to 65 kilometers per second, or around 135,000 miles per hour. The engine is made up of carbon fiber fuel tanks and cold gas thrusters. It does not utilize any propellant, therefore it emits no byproducts into space. Instead, as Ward explains, the engine generates thrust by accelerating superheated plasma with magnetic fields, resulting in no combustion byproducts. These types of engines are known as electric thrusters, but they work very differently from those used in SpaceX's Falcon 9 rockets. These thrusters create thrust by propelling pressurized gas, whereas electric ones produce a charged plasma that emits ions to push a craft forward. The electric engine developed by SpaceX is reportedly more powerful than conventional gridded ion thrusters and could power manned missions to Mars and beyond. It could also cut down on travel time for spacebound cargo because it requires less propellant, which can be expensive to launch into orbit. The technology is still being tested and further development is needed before it will be ready for space flight. It has been submitted for peer review, and NASA experts think it has potential, at least on paper. But where does the new rocket's power originate from? By bouncing microwaves back and forth inside a confined chamber, the EM drive generates a thrust. The electromagnetic fields produced by these back and forth cause an equal and opposite reaction, creating acceleration in one direction. To power it, you must use solar energy or another type of external energy source, which could be another spacecraft, such as a satellite or even a ground station receiving radio waves. Experiments with these systems, however, have so far proved unable to generate enough force to overcome drag, the slowing force caused by friction between air molecules as an object moves through them, or make any major adjustments in trajectory. Can we truly travel at such great speeds in space? Some say it's impossible to travel at great speeds through space, but Elon Musk believes he can. His plan is to develop a light-speed engine capable of transporting humans to Mars in about 70 days. Such an engine defies physics and would allow him to travel at speeds more than 186,000 miles per second. So, why is he doing it? Why did NASA pick him to fund his concept? And what may we do in space if Elon can pull off what he believes is possible? Let's look at how light-speed engines work to get answers to these problems. There are several possibilities for traveling at light speed, but first we must understand how light works. As it moves through space, it interacts with every atom in its path. This slows it down and, in the absence of substance, fully stops it. Because of these interactions, light can travel through empty space at a maximum velocity of 186,000 miles per second. Because nothing can travel faster than light without breaking physics restrictions, we must find another way to reach a distant star in our lifetime. But now the question is, how far are we from reaching light speed? The distance over time is how we measure speed. To move at light speed, or 186,000 miles per second, you would have to accelerate past the velocity until your speed reached 186,000 miles per hour, then keep it there indefinitely. Albert Einstein defined this velocity known as c in his theory of special relativity. We haven't yet reached what most people believe to be light speed, but several studies and ideas imply that we could be able to approach or even surpass it within our lifetimes. Until recently, it was widely assumed that nothing in our current state of technology could even begin to approach what we consider light speed. According to some predictions, we will be thousands or perhaps tens of thousands of years away from reaching it. That being said, we are frequently surprised by what science and technology are capable of accomplishing, and scientists have now created an engine capable of reaching a mere 10% of light speed, defying previously held assumptions about what is possible for our technological capabilities in this day and age. The development of a high-speed engine would allow humans to travel through space considerably more efficiently than before. While it will take some time to perfect, if NASA gets its way, we could see far speedier space travel within a decade owing to their groundbreaking light-speed engine. Musk's engine marks a significant advancement in humanity's ability to travel into space. This technology has the potential to transform our ability to travel between planets, explore deeper portions of our solar system, and even depart our galaxy. If he succeeds, Elon Musk will be remembered not simply as one of Silicon Valley's most popular people, but also as a scientific and engineering genius. It is a wonderful moment to be alive, but what is it? What is the procedure? Hyperspeed travel technology has been around for a while, but it has always felt like a pipe dream. To move faster than light or superluminary speed, an object's velocity across space must be greatly increased, and we are about to reach that threshold. Isn't it amazing? So what are your thoughts on this amazing technology that is just about to unveil?